Hello, Honors Geometry class. This is Thursday. I am out right now. You have a sub. Today in class, I'm going to go over section 2.6, the homework key. Following that, I will go over the 2.8 notes. You will take notes on your screen, and then you can start the homework if time remains. So here we go. Starting with the 2.6 homework, just feel free to fast forward to whatever you need to. Maybe some of this stuff makes total sense and you don't need to listen to any of it. Maybe you need to listen to all of it more than once, in which case back it up as needed. Here we go. Number one, given KMR, so let's find KMR. KMR is this angle right here, is congruent to VTW. VTW. So right away I see these are two smaller angles. We're also told that MR, so here's MR, and MP, there's MP, trisect KMO. So in KMO, all three of these angles are congruent to each other. In angle STV, which is this angle over here on the right, ray TX and ray TW trisect angle STV. So all three of these angles are congruent to each other. So because because the smaller angle of KMR is congruent to VTW, and all three of these are congruent, and all three of these are congruent, we are able to determine that KMO is the larger angle here, is congruent to STV. STV is this larger angle here. That's going to be the multiplication property. So here's what's required in the proof. We got our given information. KMR is congruent to VT. Excuse me. So KMR is congruent to VTM. So that's the smaller angle congruent to that should be VTW. Oopsie. VTW. There we go. KMR congruent to VTW. That is given to us. We also have our other given information regarding the rays that are trisecting those two angles. So you see that information in the proof. I'm going to allow you to jump straight down to KMO is congruent to STV. That's the multiplication property. Why is it the multiplication property? Well, you don't have to show this, but you should be thinking it. 3 times KMR, that's 3 times the smaller angle, is equal to 3 times VTW, that's 3 times that smaller angle. That's the multiplication property. 3 times KMR is equal to KMO, and 3 times VTW is congruent to or equal to the measure of STV. That's the definition of trisect. And so by substitution, angle KMO is congruent to angle STV. So what is in the proof over here on the left is all that's required, but it's good to know what's actually happening, like kind of behind the scenes, what is not shown there. There we go. On to number 4. So on this problem, it's a conclusion problem. It's not a proof problem. So I've got some extra stuff down here, but all you should have is division property here in the box. Let's talk about why. Angle AFE, which is that blue arc right there, is congruent to DEF, which is that blue arc right there. We're told that FC bisects angle AFE. So this blue angle has been bisected by ray FC. Same thing is happening over here with ray EB. Ray EB is bisecting this angle right here. We're trying to conclude, or we did conclude, that angle 1 is congruent to angle 2. Well, we're going from a bigger angle down to a smaller angle. The bigger angle has been bisected. That is the division property. Here's all the supporting work for it that you don't have to show, but you should be familiar with it. AFE divided by 2 is equal to the measure of angle 1. DEF divided by 2 is equal to the measure of angle 2. The measure of angle AFE divided by 2 is equal to the measure of angle DEF divided by 2. That is the division property. When two angles are congruent, their like divisions are congruent as well. So that's where the division property comes in right here in the box. The measure of angle 1 has to equal the measure of angle 2, or you might have said angle 1 is congruent to angle 2. That was number 4. All right, number 6, you might have said the division property. Let's talk about why it's wrong and why the subtraction property is the actual solution to this. Angle TNR, TNR is this larger angle here, is congruent to angle TRN. TRN is this larger angle here. Also angle NRS, NRS is this smaller angle here with the 1 tick mark, is congruent to RNS. RNS is this angle here with the 1 tick mark. Our conclusion is SNT, which is this, I'll just mark it up with this. There we go. So that angle, SNT, is congruent to angle SRT, which is right here. And we know those two are congruent by the subtraction property. Why? Well, we know that TNR is congruent to TRN. So those two in the blue box there, they're congruent. And we also know that these two, that'd be RNS and in RS, they are congruent as well. And so the subtraction property states that when congruent angles, these in the blue box, are subtracted from congruent angles, these in the blue box, then the differences, which are these two angles, are equal to each other, meaning angle SNT is congruent to angle SRT. That's the subtraction property. We're subtracting congruent angles from congruent angles. Why is it not the division property? Well, nothing is bisected. Nothing is trisected. If nothing's bisected or trisected, we cannot use the division property, nor the multiplication property. All right, number 11 is pretty tough. You may have figured it out, but it's not an easy problem. So if you struggle with it, just know that's normal. It is given that SZ, which is this 2 tick mark segment here, is congruent to ST, that 2 tick mark segment there. It helps to mark up the figure, especially on a problem like this one. Also, XY, which is that segment right there, that little small one, is congruent to VW, that segment right there. We know that Y, which is here, is the midpoint of ZX. So you're probably thinking, I'm not going to mark it up long term, but right there, ZY is congruent to YX. Also, V, which is right here, is the midpoint of TW, meaning TV is also congruent to VW. So all four of these smaller segments are all congruent to each other. We're trying to prove that SX, well, here's SX, that segment right there, is congruent to SW, that segment right there. So like the whole side is congruent to the whole side. So I'm going to erase this tick marks I just put in there. Okay, so here's what we got in the proof. We got all the given information, right? SZ, the 2 tick mark segment there, is congruent to ST, the 2 tick mark segment right there. XY, the 1 tick mark segment, is congruent to VW, the 1 tick mark segment. All that's given. Also, Y is the midpoint of ZX. That's given. V is the midpoint of TW. That is given. So, first, I'm going to use the multiplication property to show that ZX, let's find ZX right here, ZX is congruent to TW right there. Well, why is it the multiplication property? Well, remember, XY is congruent to VW. So you see this over here, 2 times XY or YX is equal to 2 times VW. That's the multiplication property. And so these like multiples are congruent to each other. Well, what is 2 times YX? 2 times YX is ZX. You see that right there. That's the definition of midpoint. And also 2 times VW, 2 times this smaller segment, is equal to TW. And so by substitution, ZX is equal to TW. You didn't have to show all this, but that is happening. You need to be thinking about that. You can just say ZX is congruent to TW. That's the multiplication property. We took our smaller segments that are congruent, we doubled them to give us ZX and TW, and those have to be congruent to each other. So now I am going to mark up, let's see here. I'll mark it up like this. TW and ZX, they are congruent to each other. So we have 2 pairs of congruent segments, and we're trying to show that ZX is congruent to back up. We're trying to show that SX is congruent to SW. And we do that by using the addition property. Why is it the addition property? Well, here's why. SZ is congruent to ST, that was given to us. So we have congruent segments there being added to congruent segments. We just proved that ZX is congruent to TW. So when congruent segments are added to congruent segments, that is the addition property. Their sums must be congruent, right? So the segment addition postulate shows us here that SX is equal to SZ plus ZX, and SW is equal to ST plus TW. That's the segment addition postulate. And by the addition property, when congruent segments are added to congruent segments, their sums must be equal. There you go. Sorry for the stumbles there a little bit. I like this problem because it uses the multiplication property and the addition property in one. So kind of rolls both of them into one problem. So this is a great problem to put onto your issues page. I would also, whenever you clip something to the issues page from this homework assignment, I would include my extra information there off to the side so you understand why is it the multiplication property? Why is it the addition property? The supporting work off to the right really helps you out. Oh yes, we're back to these problems. Number 14. If 4 times the supplement of an angle is added to 8 times the angle's complement, the sum is equivalent to 3 straight angles. Find the measure of the angle that is supplementary to the complement. So I got the angle of x, I got the supplement 180 minus x, I got the complement 90 minus x, 3 straight angles, that's 3 times 180, which is 540. So let's read the problem. 4 times the supplement of an angle, that's 4 times 180 minus x, is added to 8 times the angle's complement, that's 8 times 90 minus x. The sum, right, what we're adding here, is equivalent to 3 straight angles. This is equal to 540. We solve this equation, we get x equals 75. This says find the measure of the angle that is supplementary to the complement. So if we know the angle is 75, the complement is 90 minus 75, so the complement is 15. Well, what is supplementary to a 15-degree angle? Well, the supplement of that complement is 180 minus 15, or 165. There you go, number 14. All right, that's the homework. Let's go on to the notes now. All right, so I've already filled this out, so you can just pause the video and write down what you need to. I'm just going to talk about it here. We're talking about vertical angles today. You may already know about this. I know I teach it to the 7th grade class. Now, it shows up very briefly, so if you have me in 7th grade, you may not remember, and that's okay. But you may have learned it from another school or another teacher, whatever it may be. But today's the day we learn about it in geometry. So here we go. Here we have a figure, right? Angle 1 and angle 2. Think about how they're related. They're supplementary. Think about how angle 2 and angle 3 are related. They are supplementary. So both 1 and 2 and 2 and 3, 2 shows up in both those, right? Meaning angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 2. Well, we've learned from this chapter, angles with the same supplement are congruent. Angles, angle 1 and angle 3, with the same supplement, they both have angle 2 as a supplement, are congruent. So that lets us know that angle 1 and angle 3, they are congruent to each other. Let's do the same thing with 2, 3, 4, and 3. So angle 2 is supplementary to angle 3. They form a straight angle. Angle 3 is supplementary to angle 4. They form a straight angle. So both angle 2 and angle 3, angle 2 and angle 4 have angle 3 as a supplement. So when angles, angle 2 and angle 4, have the same supplement, they both have angle 3 as a supplement, those angles are congruent. So if angles have the same supplement, they are congruent. Therefore, angle 2 is congruent to angle 4. So anytime you have this X shape, this X shape showing up, you know the opposite angles, in this case 2 and 4, and 1 and 3, they have to be congruent to each other. So there you go. So in example 1 here, angle BUM is this angle right here, is congruent to angle TUG, which is that angle right there. So sometimes it's not super clear. So if you can like create BUM by extending out these lines, this is where OneNote really comes in handy sometimes. You can see very clearly BUM and TUG, they are opposite one another. So that one's a pretty clear one, but it's not always super clear. Name another pair of vertical angles. This is probably where it's not super clear here. Angle BUT, right? BUT is formed by this ray and this ray, or line segment, I guess, right? BUT is this line segment, and this line segment. So here is angle BUT, and you can see angle BUT is opposite angle GUM. So when you highlight it there, it becomes a lot clearer as opposed to before we highlighted it, maybe not quite as clear, right? Hard to find that second pair because it's a little busy here with NU. So use OneNote to your advantage to create those X shapes. So there you go. Try example 2 on your own if you can. Pause the video if you have not. And here we go. Example 2. Given that angle 5 has a measure of 4x plus 13. So here's angle 5. And angle 7 has a measure of 9x minus 22. There's angle 7. They are congruent to each other. Find the measure of angle 6. So angle 5 is congruent to angle 7. 4x plus 13 is equal to 9x minus 22. X equals 7. Find the measure of angle 6. Well, the measure of angle 6 is 180 minus the measure of angle 5. That'd be your geometric statement there. We know what angle 5 is. 4 times x, that's 4 times 7 plus 13, which is 41 degrees. We then subtract 41 degrees from 180. 180 minus 41 is 139 degrees. So there's example 2. Try example 3 on your own. Pause the video now if you've not done so. And here we go. Given HE bisects angle WHY. So here we have angle WHY. HE is bisecting it. Right away, I'm thinking like, okay, we might have some like division property at play here. We might have some multiplication property at play. Maybe I'm using like definition of bisect to show that 1 is congruent to 2. Just all those are on the table. Also, we know that angle 2, well, let's mark that up. There's angle 2 is congruent to angle 3. All right, well, let's think for a second. What is 2 congruent to? We just learned that 2 is congruent to 1. Let's go over here on the right. We know that 3 is congruent to 4 because those are vertical angles. So we got vertical angles happening. We've got angles that are bisected happening. We're trying to show or prove that angle 1 is congruent to angle 4. Well, we know all 4 of these are congruent, so 1 is going to have to be congruent to 4. The hard part is putting this in a proof. So here's what this looks like. First off, HE bisects angle WHY. That is given. That's my first statement and first reason. I then built upon that. You could have put the other given information in right there. That would have also been acceptable, but I just went ahead and built upon it. Angle 1 is congruent to angle 2. That's the definition of bisect. We also have our other given information. Angle 2 is congruent to angle 3. Well, let's look at this for a second. If 1 is congruent to 2 and 2 is congruent to 3, we can use substitution, right? So imagine I'm taking this 2 out and I'm putting 3 in its place. So we substitute 3 in the place of that angle 2. And we end up with what we have at number 4. Angle 1 is congruent to angle 3. That was substitution. Also, we know angle 3 and angle 4 are vertical angles, so they are congruent. This is the reason in the proof. Angle 3 is congruent to angle 4, vertical angles. And again, right, thinking about substitution, we know that angle 1 is congruent to angle 3, and we know angle 3 is also congruent to angle 4. So I can take that angle 3 out, and I can put angle 4 in its place, meaning angle 1 is going to be congruent to angle 4. Do you see that right there? That is substitution. Angle 1 is congruent to angle 4. A lot of kids, this happens every single year, they try to say, well, can't I just say, I guess they try to take out, kids try to take out this step right here. They try to take that out. They list 1 is congruent to 2. They list 2 is congruent to 3. They list 3 is congruent to 4 by vertical angles. And then they tell me 1 is congruent to 4 by substitution. So don't do that. You're leapfrogging over this fourth statement. Remember the logical chain of reasoning? If A, then B, if B, then C, if C, then D. So we have to create this chain of reasoning. And I'm pretty flexible on some stuff. This is something I'm not flexible on. there has to be a chain from one to the next, one to the next, right? 2 shows up here, 2 shows up here. So by substitution, 1 is congruent to 3, okay? And then we have 3 showing up here. We have 3 showing up here. So by substitution, 1 is congruent to 4. So it has to be this chain just like this. So it doesn't have to be exactly in this order, but I don't want this to become a 5-step proof. So just be aware of that in the future. All right, well, that's the end of our notes today. Please complete the homework assignment to the best of your ability. Tomorrow we have a worksheet day, which should be a good time. Best of luck to you, and I'll see you next time.